It's spring here, and our perfect random number generator is just about to launch. To the moon, of course. So let's just flip it. And the blockchain department wins this time, but I will actually start with a topic that is shared by both departments, and that is the Go language itself, that is used for almost everything NeoSPCC does. A new version of Go was released in February 1.22. This is the latest and greatest of Go, so we have transitioned all of our software to use it for builds by default. But that's not all. It also means two things. First is that Go 1.20 is technically obsolete now, because Go authors only support current version and one previous. But second is that there are new features in the standard library and sometimes even the language itself. The way we handle these is that we update all of our packages, and I really mean all of them. We currently have a little less than 20 repositories with Go code to drop support for older Go, but we keep supporting one version more for your convenience and use new features available in the minimal supported Go version, which is 1.20 in our case, when they are appropriate, of course. Since we're touching each and every repository, this is also a nice point to update all of our dependencies, so we did that as well. This is what we call a properly maintained software. This process was recently outlined in our document, so you can take a look at it as well. The end result at this stage is that all of our packages now require Go 1.20 or more recent to build, and almost all packages had some versions released just because of that, even if there were no functional changes. I won't mention all of them, of course, but if you are using any library or package of ours, consider updating as well. Believe it or not, but we had no releases of NeoGo during these 2 months. This doesn't mean we have stopped developing it, of course. In fact, we have solved a lot of problems and implemented associated protocol changes from the C# node. We have solved all problems we had with tests. They are greener than ever. But we are currently sitting on a huge set of unreleased changes and waiting for C# node 3.7 to settle. Once it's there, we'll flush them all out in a new release. Expect more features to come next. As a part of Bane effort, we have significantly refactored our dBFT library and released a version 0.2.0 of it. Many dependencies were just removed, including the most problematic one, because we had dBFT library depending on NeoGo and NeoGo depending on dBFT library, so it's a circular dependency, no good, but now it's gone. The interface was streamlined in many cases, some unused duplicating hooks removed. It's a very nice work overall that allowed to reduce the package binary 3-fold and also allowed to remove some lines from NeoGo just because it's easier to work with the library now. So if you need a stable, clean dBFT implementation that is easy to integrate into just about any project, is there. The next step for dBFT is modification for anti-MEV feature, and that will start soon. Likely you have seen T2 testnet of NeoX, and T3 is somewhere near as well. If you see any of them working with blocks produced regularly by 7 validators, this means we've done a good job at stabilizing the consensus part of it. In fact, there was an incident in T2, partially related to already known missing checks at that time, but it was solved, as well as some tens of other things that were previously intentionally postponed to post-T2 development. Currently, all known problems are solved and dBFT integration is considered to be stable. But we will start breaking it soon, sorry. Anti-MEV feature is pretty invasive and touches on many components. Don't expect it to be delivered quickly, it needs some time to be done correctly. Follow official announcements and stay tuned. We have deprecated and archived one of our smaller libraries, known as neofs-crypto. What? You don't know what it is? Okay, it was a small library that intended to have all of NeoFS cryptographic primitives in one place. It was duplicating many of NeoGo functions from the beginning. We've used just a pair of its functions up until recently, and now it's just gone. Replacing it is trivial with NeoGo and neofs SDK. We have deprecated and archived our neofs-testlib repository. What? You know nothing about it either? Okay, it contained a library for neofs tests, dealing with network setup, service configuration, CLI operations, and things like that. We've noticed that the only user of this library was the repository with NeoFS test cases, and in practice this separation that we had slowed us down somewhat, because some changes to the testing system required modifying the library and going through full release cycle before it could be used by test cases. So this code is not gone, it was just moved to NeoFS test cases and will be maintained there. But in fact, the main reason I wanted to tell you about it is to highlight our NeoFS test suite that is being expanded every day now. It was recently made to be independent of NeoFS development environment, greatly expanding our abilities to test complex scenarios. And this can be a nice project for you to get to know NeoFS better and do something useful if you want to help our community. It's all Python, so much lower barrier to entry, and there is a number of relatively easy to solve issues that are marked appropriately. Take a look at them and try our test suite if interested. Neo Exporter was updated to version 0.11.0 with a fix to node rebalance tracking and usability improvements. So I'm just reminding you about this tool that you can use for network monitoring. S3 Gateway was updated with a new version 0.30.0. Changelog is rather big there because we've solved many incompatibilities, done some optimizations, including big ones in memory management area and multi-part handling. Added support for AWS chunking and solved some inconsistent replies in areas that we don't currently support. Overall, a very good release. As was promised previously, we have finally deprecated and archived our HTTP gateway. At this point, we don't even have public instances of it, and our old HTTP/FS Neo.org domain and its testnet counterpart are served via the new REST gateway. We recommend proper migration though, because these domains will eventually be discontinued as well. There is a migration guide available. For the most part it's trivial, and we have not seen any real-life regressions at this point, which is exactly what we wanted to achieve by providing compatible API. As for the REST gateway itself, we've made a series of releases bringing and fixing this new functionality as well as some older APIs. But I have to confess, at some point, and this is 0.8.0 release, we have almost completely rewrote it. We couldn't fix some of the problems without doing this because old code base was relying on OpenAPI 2.0 specification and associated tooling. OpenAPI 2.0 itself is long obsolete, and the tooling used stayed at this version with no migration path provided to 3.0. So when we realized that we can't solve some of the problems without OpenAPI 3.0, we had to also change to a different framework for code generation and API management. This was done, and again at this point we've kept all of the old APIs compatible. So it's all transparent for you. But for us, it adds many new abilities to evolve the gateway. Grab the latest release of the gateway and try yourself. As for the future, there will be some changes related to NeoFS development, but what we also want to do in some near future is to provide additional object APIs. We have a situation where the ones that were originally made for the REST gateway work perfectly with attributes, but are not very efficient for big objects. And the API inherited from the HTTP gateway works perfectly with big objects, but can be a problem when dealing with custom object attributes. So the goal for us is to provide an API that handles both fine. And don't worry, the old APIs of course will remain for compatibility reasons. The last thing we want is to break your applications, so we will handle this carefully, as we've done with previous changes. I have not talked about it in previous episodes, but we have been quietly working on Panel for quite some time, even though, all of our repositories are public, so really curious ones could have seen it. And most likely you also know already that we have launched a public instance of it, with a whole dedicated video presenting its current features, so I won't repeat here. I will just highlight that it's important not just on its own, but also in a combination with other things that we do. For example, we've got a GitHub action to upload things into NeoFS, which, by the way, was recently updated with some new flags. To use it, you need a wallet with account that has some gas deposited to NeoFS and a container. While the wallet part is rather obvious, Deposit and container is not so much. With panel, you can handle both easily and use GitHub action then to upload data. We have seen new deposits to NeoFS contract, and we have seen new containers created in NeoFS since the release, which is inspiring. We have also received some feedback, and be sure it will be addressed. And panel will be improved and polished over time. It's a user interface in its essence, and you know how it goes. There are always things to improve. Move some buttons around, reword some messages, clarify some parameters, it's endless. But in fact, we want even more feedback from you, so if you have some ideas, if you have noticed some rough edges, our GitHub is widely open for you, as usual. Now let's talk a bit about NeoFS itself, because, no REST gateway or panel could be possible without it. We have released 2 new node versions, mostly dealing with bugs of various kinds, nothing really special there, but both mainnet and testnet are using 0.40.1 now, and you should too if you are running nodes or using CLI. But what's more interesting though is things that we are preparing for the next release that's gonna happen in April. NeoFS has limits, and one of these limits is the maximum possible object size, which for mainnet is just 64 megabytes. Doesn't sound like a lot, right? But you know that we store larger objects as well. Typical NeoFS test report can be around 100 of megabytes. Some videos that we also have are easily gigabytes. So the way they work, in fact, is by splitting these large payloads into a set of smaller ones. And it's inevitable. If large objects were not split, we would have serious problems with replication, disk space, and others. So large objects are handled as a set of smaller ones, and of course, the split can be done in various ways. Historically, we had a protocol for that, but over time it became clear that it's insufficient. It relied on headers for the so-called linked objects that are in fact just an index of these smaller ones. Back when it was designed, headers were not officially limited. Because of implementation specifics, you couldn't have more than 4 megabyte header, which in fact already limited the size of the large object, but 4 megabyte headers are a problem of its own. Headers are not supposed to be that big. They are used much more often than payloads, and they better be small. So we have limited them now to 16 kilobytes, and this has limited large objects even further. Then the old structure was also highly inefficient at seeking. So if you needed some chunk of the object, say 100 megabyte from the 1 gigabyte offset, the node couldn't handle the request unless it completely walks through this first gigabyte. But even that was not the biggest problem. Old split scheme had also not allowed for proper extended ACL processing. Some rules that worked just fine for small objects were completely impossible for large ones. To solve all of these problems, we have designed a new split scheme that is already implemented, tested, and, you wouldn't believe, even documented. Of course, the old scheme is kept for compatibility. We already have large objects using it in our networks, so these objects will still be available. But starting with the next release, all new large objects will use an updated scheme, providing more possibilities for your applications. We have added a new replication API for more effective communication between storage nodes. This doesn't affect applications, but gives better results in various scenarios. With improved inter-node communication, we now also see some limitations of the gRPC protobuf scheme that we use, but these won't be changed in the near future. Already added and tested are protocol changes that allow you to have extended ACL rules based on numeric values, as well as perform search for objects with numeric comparisons. NeoFS always had support for arbitrary object attributes, so you always had ability to have something like block index or page number or movie rating, depending on your application of course, stored in attributes, and you always had ability to use trivial equality inequality attribute-based filters. Now, suppose you have an ML dataset with numeric labels like number of people on a picture. It was always possible to search for pictures that have 3 or 5 persons, but you could not do a search for pictures with more than 5 or less or equal to 10. That's what the feature is about. With the next release, you will be able to, as well as use these expressions for extended ACLs. It's especially handy if you want to use some system attributes like epochs or object sizes. You will be able to impose any restrictions on them for upload or download. Like, you want to give some access to upload objects that are not bigger than 100 megabytes. Wait for the next release to come and you will be able to. One of our next steps planned for the nearest future is dropping one more repository. This time it's neofs-api-go. For quite some time we had this structure with a completely abstract neofs API repository that contains protobuf and gRPC definitions only. Then neofs API-go repository that contains minimalistic Go implementation of these definitions, mostly auto-generated. And then on top of neofs API-go, we have neofs SDK-go that adds a lot of sugar and support code to make the API easier to digest. In this structure, applications were always supposed to be using neofs SDK only. For the most part, that was true. But in some cases, direct API-go uses still crept into code. This just tells us that SDK needs to be improved in these areas. The other thing is that API-go was never supposed to have any meaningful code of its own, providing gRPC API only. But it still got some over time, especially in areas of connection and signature handling. So these original goals were not perfectly satisfied, and at the same time the only valid user of API-go was always just the SDK-go. And each and every protocol change, and you have noticed probably that we've done quite a number of them recently, had to go through API-go first to then be implemented in SDK. This slows us down for no good reason. So we've decided to drop API-go completely and do everything in SDK. This is in progress, but it will be done. Any applications using SDK won't be affected. We are also working on a new version of Session Token. The old one is not convenient to use because of its protobuf structure. It's limited to a single key and action, so to overcome these problems we've started designing an alternative solution, and you can get a bit more details about problems we want to solve in this issue. This has just begun, but I hope we will be able to roll it out with 0.42.0 release of NeoFS, not in April, no. We will soon start a work related to metadata handling in NeoFS. It's a huge topic that I won't dive into a lot now, but currently we have an experimental tree service extension that tries to solve a part of this problem. But it's experimental and has some known limitations. Like, for example, it can't be used safely on mainnet, so it's disabled there. We will explore alternatives and try to find a combination that satisfies all of our requirements. But don't expect it to be done soon. The next time I will probably talk about it is some 4 or 6 months away.